Number 7 then, from the 2016 Advanced Higher Mathematics of Mechanics. What have we got here? Maximum speed and kinetic energy. And it's given acceleration. Acceleration, you've defined speed, etc. Right, what does it say? An object of mass 9 kilograms starts from rest. Yeah, starts from rest, that's important. Moves in a straight line, linear motion, so its acceleration is given by this. A equals 4 minus root t. Calculate its maximum speed and hence the increase in kinetic energy. Maximum speed. Well, its speed will keep increasing as long as it's accelerating. Now, according to this, its acceleration is going to decrease with time, but nevertheless, even though the acceleration is decreasing, it will still keep increasing speed until the acceleration reaches 0. So you've got this. Maximum speed is reached when the acceleration equals 0. So 4 minus root t is 0. Root t is 4, so t is 16 seconds. It'll happen after 16 seconds, it'll get to its maximum speed, because after that the acceleration is going to go negative and it'll start slowing down. So that was the first mark of the 4. Now, what is the maximum speed? Well, A equals dv by dt, which means dv by dt is 4 minus root t. So v will be the integral of 4 minus root t dt. And now you've got a choice of 2 ways of doing this. You can either integrate that to get the formula for speed and then put the time into it, or you could integrate it over the time interval. I'll do it the indefinite way first of all. If you just integrate that, you're going to have 4t minus, now that's a half, so it'll go up to 3 upon 2, so t to the 3 upon 2, but divide by that, 2/3. But if you do it that way, you can have a constant. But you knew the initial conditions. It started at rest. When t was 0, v was 0. That means 0 equals 0 minus 0 plus c. That means c equals 0. So that means you know the formula is just v equals that. I think I'll take the t out because that's t times root t. So if you take out 2t, you'd be left with a 2 minus, and I've still got a root, I might just put it as a third, minus a third of root t. Or just leave it without a bracket. Now if you do it that way, this gives you a mark, but only if you've shown that this constant equals 0. Room rapidly here. So from that now I can get the maximum speed would be v equals, it happens when t is 16, so it'll be 2 times 16 times 2 minus a third of root 16. A third of root 16 is a third of 4, that's 4 upon 3, that's 6 upon 3, so that's 2/3. So that's 4/3 of that, so it's 4 times that, so it's 64 upon 3. 64 upon 3 metres per second, which you may want to put down as then 21 and a third, 21.3, would that do, rounded off, metres per second. Seems to have left it this way in the marking scheme. Now, that's a mark. Now for the last part, I'll just do that up here. What was the last part again? What does it say? Blah, blah, blah. Calculate its maximum speed. Done it. Oh no, there's the other way, of course. The alternative to having to find that constant would have been to say straight away here, maximum speed will be from 0 to 16 of that. Just integrate that acceleration over the time it was still had a positive acceleration. Then you would say, well, that's going to be 4t minus the 2 upon 3 t to the 3 upon 2, I suppose, from 0 to 16, and then put the 16 in. Now the constant doesn't really matter. So 4 times 16 minus 2/3 of, unfortunately that's going to be that 16 to the power 3 upon 2, minus 0 of course when t is 0, which of course just comes to the same thing, 64 upon 3 metres per second. That would still have been the third mark, so although it's not indicated in the marking scheme, then that mark, second one, should surely have been there rather than getting an explicit formula. Well, I suppose that's tucked in there. Now, the last mark. Very simply, calculate the maximum speed, done it. Hence the increase in kinetic energy. Well, quite simply, it started at rest, so the increase in kinetic energy will be whatever its final kinetic energy was. So its kinetic increase in kinetic energy, or maybe you could say the increase in it will be, is going to be a half mv squared, or v max I should say, minus 0 because it started at rest. So that will just be a half of, and it had a mass of 9. A half of 9 times, oh that's quite handy, that 3 now, although the 64 squared is not that handy, over 3 squared, minus 0, so that won't matter. At least the 3 squared knocks out the 9. 64 is 2 to the power 6, you always remember that, 2 to the 6 is 64. So that means that's 2 to the 12, knock out 1, that's 2 to the 11. Now 2 to the 11 is quite handy, because you remember 2 to the 10 as well, because that's 1000, well 1024. So doubling that, 2048 joules. Or do they want that rounded off just to 3 figures? Because it said to 3 significant figures, 2050 joules. Now, if you are looking at the marking scheme, you might see another alternative for finding, you still had to find that maximum speed. An alternative for finding the increase in kinetic energy, which is the work energy principle. The work done equals the increase in energy, just kinetic energy in this case. It suggests you'd be doing this. Oh, work done, that's force times distance, or since it's a varying force, F, I'll put distance as S of course, I don't want to confuse the differentials, F ds. And then you can mess about with however you put this down. So it's suggesting that you use the form of f and then put ds by dt, the dt, which gives the integral of f v dt. And then it's saying, oh, f equals ma, that's a constant, m's constant, av dt. And then carrying out an even worse integration than this, just for this little final mark here. Because I'd have to put into this integration, of course, you'd be integrating from the start 0 to 16, and I'd have to have my expression for a in. Oh, I'll put it down. Well, that was 9, wasn't it? It would be from 0 to 16 of, it'd be 4 minus root t times, and the expression for the other one was 4t minus 2/3 of t to the 3 upon 2 dt from 0 to 16. But who would do that? You wouldn't do that. No, that would just be daft. If you were going to do this integrating the work thing, then you would simply have said, well, f equals ma. Let's just pop that m out of there. A ds, but a is dv by dt ds. Let's just shugle our differentials here and make that ds by dt dv. So that's the integral of mv dv, which is, lo and behold, at half mv squared. You would just go in for half mv squared, wouldn't you? You would never do that integration thing. So that's the way you should have done it here.